I'd like to welcome you to a discussion of a new quantitation feature, Standard Addition. So let's discuss what the reasons are for turning to Standard Addition. First, Standard Addition is different, quite different than creating a calibration curve from calibration samples. The technique actually introduces the target compound directly into the analytical sample. So a very different methodology. Now, why would you do that? Well, one reason is you've got a complex sample and you cannot find a matrix blank or a matrix standard that is consistent. In other words, each sample that comes in potentially has a different matrix background. Another reason is you can't figure a sample prep methodology that will remove co-eluting matrix peaks, and those matrix peaks end up suppressing some response. We're going to make some assumptions here. One of them is that the response is linear where we are doing the sample concentration. And the last reason is if you're just doing a small number of analytes and you want to quickly develop a method, then Standard Addition looks appealing. Let's look at this pictorially. As I mentioned, we have our solution that we're going to determine the concentration. And what we're going to do is to add incrementally a spike and then another spike, and we're going to do this maybe a third time. And each time the spike concentration increases, so we're able to draw basically a calibration curve from these known amounts that are added to the original sample. Here are some equations, but I'm going to try to give a blue-collar explanation. If you look at this calibration curve, if you excuse me calling that, you'll see that the original sample here is at 0. And then we've gone ahead and we've added a spike, which gives us a greater response. So it's the area of the unknown plus the area of the first spike, and then very similarly, there's the area of another spike. And you get this line that has a slope. So we are able to calculate a response factor, and the concentration is basically the area of the unknown divided by this response factor. And the response factor is obviously related to the slope of this line, and that will back calculate the concentration of the unknown. To get started here, let me show you how to turn this on. So we're going to go over to Global Setup, and we're going to turn on Standard Addition. Now, when you've done that, all of the samples in the batch, all of the compounds are going to be treated with this Standard Addition calculation. So I will show you that I have setup level concentrations that I'm going to use in the Standard Addition methodology, and basically this defines, when I use level 2, the spike concentration that would be present in each. So with that set up in place, let me next show you the application to samples in Batch at a Glance. All right, let's go over to Batch at a Glance. And what we'll see that I've got set up here is a sample and then calibration samples that follow. So the assumption that we're going to make in Standard Addition is that a sample followed by calibration samples means the next calibration sample are spikes, and the level concentrations associated with those calibration samples defines the spike amount. Now, with that assumption in place, you can see I've got basically two samples here. A sample that has a determined concentration related to the calibration samples that are following it, then a blank, and then again another sample with calibration that follow. So that gives you a picture of how standard addition needs to be set up to work. Notice, of course, that the calibration curve is linear and the origin is ignored, weighting none. That will be done by default. Additional points I'd like to make. As with relative ISTD, there is an assumption that the order that the samples were acquired determines the order in which they're analyzed. So this sorting of acquisition date time is very important in standard addition, the sample followed by the respective spikes. And next, in standard addition, as previously pointed out, it's useful to have the spikes in the same concentration area as the sample. So it is necessary sometimes to dilute the sample and redo the acquisition to determine a more accurate concentration. So if you look at the final concentration here of 12 roughly, and I do a dilution, you'll notice that that concentration doubles. In a very similar way, I'll do that with the first sample here. I'll double the dilution, and you'll notice that the concentration has doubled. So the calculations from standard addition enjoy the same benefits of the quantitation engine and the calculations that go through with sample amount corrections. So I hope you find that useful. Thank you very much.